All right, in our number 10 here, we're going to fill out our facts. So x-intercept we get by looking at the numerator. So x minus 3 equals 0 means it's going to cross at 3, 0. The y-intercept we get by evaluating it at 0. So if I do 0, so 0 minus 3 over 0 minus 1 squared, well, that's going to give me negative 3 over a positive 1. So I get negative 3 for that. Vertical asymptote is going to have, let's see, it's x minus 1, so it's just x equals 1. It is in fact a bottom-heavy rational. It's got an x squared in the denominator than the x, so its HA is y equals 0. And then the question is, does it cross the HA? So I'm going to set the horizontal asymptote equal to the original equation. And let's see, so I multiply across, I get 0 equals x minus 3. So when x is 3, so it actually does cross it at 3 comma 0. Okay, so then I'm going to come over to my graph, and I may or may not need to find some more information depending upon how my picture shows up. But let me start with any asymptotes. So at y equals 0, there's an asymptote. And at x equals 1, there's an asymptote. I know that it crosses at 3, 0, so right there. And I know there's a y-intercept of 0, negative 3, so down there. That's about it. Okay. Well, what I know, a couple things I can tell just because of how the graph works. So on the left side, I know it's going to approach that vertical asymptote, and I know it's going to approach the other asymptote. So I know the left side looks like that. The right side, what I don't know is I don't know if it goes up or down. And I'm not sure if it's going to stay above the intercept or below the intercept. So there's two decisions that I am not really 100% convinced of. So I need to know between 1 and 2, so say 1.5, whether it's positive or negative. And then I need to know something past 3, so 4 would be a good number to test. Okay, so I'm going to go to factored form, and if I put in a 1.5, I get some sort of negative number, and if I do 1.5 minus 1 squared, I get a positive number, which means it's negative. And do the same thing with the 4. So I'll put a 4 in and a 4 there. So I get a positive, positive, which tells me positive. Okay. So as far as my graph is concerned, so this piece being, that side being negative, so it's got to come in through there. So I can get rid of that. And it stays positive, so it's going to come in through there. But I needed to do the table in order to see that. Okay, so the first thing up is to factor this thing. So let's see, that would be x minus 2 and x plus 1. And down below, let's see, x plus 3 and x minus 2. Okay, so the minus 2's cancel out, which means there is a hole at 2 comma something. And then in the reduced form, I have x plus 1 over x plus 3. Okay, so then I want to take that 2, plug it into the reduced form. So that gives me, what is that, 3 over 5. Okay, so there's a hole at 3/5. Then for every other fact from here, I want to look at just the reduced form. So the x-intercept I get by looking at the numerator and setting that equal to 0 and solving. Y-intercept I get by evaluating the reduced form at 0, so 0 comma 1/3. Vertical asymptote by looking at the denominator. HA, this is what's called the same case, so it's looking at the leading coefficients there, so you can imagine they both start with a 1, so reduces down to 1. And then does this cross the horizontal asymptote, so let me set the HA equal to the equation, and let's see, so if I multiply that across I get 1 times x plus 3, so that's x plus 3 equals x plus 1. Now when I try to get the variables on the same side, I end up canceling out the variables, and then I get a false statement. So the answer here is no, it actually doesn't cross. Okay, so since it doesn't cross, let me plot what I know then. I know that there's a VA at -3. Oops. I'm going to draw that in. Now there's an HA at y equals 1. I know there's an x-intercept at -1, 0 right there. And at 0 comma 1/3 is a y-intercept. And that's it. And honest, oh, and I got a hole. There's a hole at 2 comma 3/5. Okay, so on the right side, I know it's going to go through that. So it's going to look like that. Make sure it goes through the hole. On the left side, okay, so I have to have a decision with myself here. Either it's going to be above or below on the asymptote. Question is, can it be below? And the answer is actually no. The reason is it didn't cross the x-axis on that side. So there's no way it's ever going to be below, so it's got to be above the whole time. So that's what my picture looks like. Okay, we're going to factor this one first, if we can. Okay, so let me see if this is right. X plus 4, x minus 2 over x plus 5. Is that right? That's plus 4, that's minus 2. So, yep, that works. Okay, so there's factored form. X-intercept, I'm going to look at the numerator. So -4, 0, and 2, 0. Y-intercept, I'm going to evaluate the original function actually at 0. So 0 squared, a lot of that stuff cancels out. I'm actually left with -8/5. Domain, the only number I'm going to kick out would be the -5. Let's see, union -5 to infinity. Vertical asymptote is x equals -5. That comes from looking at the denominator. It's actually top heavy this time, so now we need a slant asymptote, which means I'm going to divide. So let me set up my synthetic here. 1 to -8, and I want to divide in the -5. Okay, so drop the 1. It gives me -3. That gives me +15. That gives me a 7. And as far as the slant asymptote goes, it's y equals, and it's that set of numbers there that represents x minus 3. I don't worry about the remainder when it comes to the slant. Now, does this graph cross the slant? So let me take the x minus 3 and set that equal to the original function. Let's see, and we want to multiply across there, so x minus 3 times x plus 5. And let's FOIL that out. So x squared. Let's see, plus 5 minus 3, so that's plus 2x minus 15 equals x squared plus 2x minus 8. Ooh, I see it. All right, notice the x squareds cancel out, the 2x's cancel out, and I get negative 15 equals negative 8. That's false. So it does not cross the slant asymptote, which is pretty common. All right, so let me graph my asymptotes here. So x is negative 5. All right, so there's the x equals negative 5. Y equals x minus 3. Comes down at negative 3. Up 1 over 1. It's got a slope of 1. So nice thing is I can just use my graph paper to kind of see that. Let's plot some points then. So negative 4, 0 is right there. And 2, 0 is right there. Negative 8 fifths. It's like negative 1 and a little bit. So right in there. Okay. So I can see on the right side it's going to come down, curve, and then hug out that way. On the left side, and I'm going to have to extend my picture on. Alright, because either it's above or it's below. So think about it logically. If it's above, it means at some point it's got to come across to hit the x-axis. But I already wrote down everywhere it crossed the x-axis and it didn't do it over there, so it's got to be on the other side. So it's got to curve down below, so we wouldn't even see it on our graph unless we extended the picture down like I did. Alright, so number 13, let's start with our facts of what the parent graph looks like. So this thing is based off of 4 to the x, which has the ordered pairs of negative 1 comma 1/4, 0, 1, and 1, 4. And it's got an asymptote at y equals 0. And that's just based off of our pattern from class about finding ordered pairs from exponential functions. All right, our mapping. So what happens to our ordered pairs? According to our transformation, it's the x minus 3 in the exponent says we're going to add 3 to the x's, and we're going to add 2 to the y's. Okay, so I just need to go through all 4 of my facts and do that. Let's see, add 3 to the x's. Puts me at 2, and that's 2 and 1/4. 0, 1, let's see, so 0 plus 3 would be 3, 1 plus 2 is 3. 1, 4, so 1 plus 3 is 4. 4 plus 2 is 6. And y equals 0, well, that means the asymptote actually moved up to 2. Okay, so let's plot these. 2 comma 2 and 1/4. So 2 and a little bit. 3, 3 is right there. And 4, 6. And we got this asymptote at 2. Okay, so we're going to hug the asymptote, hit our points, and cruise on up. And so that's what our graph looks like. Okay, next task is to find the ordered pairs for this parent. The parent would be e to the x, so that would be negative 1 comma 1 over e, 0 comma 1, 1 comma e, and an asymptote at y equals 0. All right, our mapping rule. The only thing that's going to affect the x's is that x plus 2, so that means we're going to subtract 2. The y's have the 3 and the minus, so it's negative y plus 3. Okay, let's see. Then I'll just plug in all my information and see where it puts me. Negative 1 minus 2 is negative 3. And this actually is negative 1 over e plus 3. 0, 1 puts me at negative 2. And that would be negative 1 plus 3, so that puts me at 2. And 1e, so 1 minus 2 is negative 1. And that's negative e plus 3. And my asymptote actually moved up to 3. Okay. Alright, so let's see. Asymptote, I can get that in pretty quick. And let's see, negative 3. Okay. Well, I know it's got to be really close to 3. It's not quite at 3, so a little less. Negative 2, 2. I know where that is. So negative e plus 3. So e is about 2.71. So that's almost 3. So at negative 1, I'm a little bit bigger than 0. So hopefully you can see what's going on here, that our graph is going to curve down and look like that.